Rational zero theorem, also known as the rational root theorem. Either way, again, zeros and roots mean the same thing. Rational root theorem will help you find all of the places that any polynomial where it crosses the x-axis. So that's what this whole chapter has been leading up to, is this rational zero theorem, which uses synthetic division. That's why we have done that all along in this chapter. So this is the most important part of the chapter. This is what we did all the other sections to lead us up to this. And since we have done all those sections, this really isn't that difficult. It's nothing really new at all. So we're looking again for all the places where a polynomial crosses the x-axis. So if we have the function f of x equals 2x to the third minus 11x squared plus 12x plus 9. If I told you I want you to find out all the places that crosses the x-axis, many of you would not at this point be able to do that. You could if it was quadratic. You could use one of the methods we covered in Chapter 5, but since it is cubic, or if it were a quartic or quintic especially, you wouldn't be able to find all the places. How many times, or how many zeros should we find for this one? 3. That's how many we have to find. So what the rational zero theorem does is allows you to find all the possible places, and then you just start testing them one at a time. The way that you will list out the possibles, you write all of the factors of 9 for this problem, so whatever this is, whatever the constant is, all the factors of 9 divided by all the factors of 2. So this first number, all the factors of the last number divided by all the factors of the leading coefficient, which in this case is 2. So what are the factors of 9? 9 and 1 and 3 and 3. You do not have to list the same one twice. So 3 times 3 are the factors of 9, but if you've got a 3 there, you don't have to list it again. And what are the factors of 2? 1 and 2. So you list all the factors of 9 divided by all the factors of 1. So your first one there, you're going to do 9 over 1 and 9 over 2. 1 over 1 and 1 over 2. 3 over 1 and 3 over 2. So 9, go ahead and simplify. 9 over 1, don't put 9 over 1 over here. Just go ahead and make that 9. And then also 9 halves. So we've done the 9. We've taken care of that. So the next one would be 1 over 1, which is just 1. Again, don't write 1 over 1. And then 1 over 2. And that one's done. So what would our next one be? 3 and 3 halves. How many possibilities do we have there? 6. But I'm going to double that because you have to test positive and negative. So plus or minus 9, plus minus 9 halves, plus or minus 1, and so on. So now how many possibles do you have to test? Well, you've got to test all 12 of them. Start with 1. Start with your whole numbers. So I would do plus or minus 1 and plus or minus 3 first. And then you can either go to the 9, which normally it's not going to be that high, or you can go to your common fractions. Like 1 half is obviously a very common fraction. 9 halves is not so common. So that's just kind of giving you a heads up which ones to try first. So if we try the 1, we're going to synthetic divide again by every single one of those possibilities. How will we know If it's a 0,
We'll have no remainder.
you will have no remainder. So we try all those numbers until we end up with a 0. Are we missing any terms up here?
No.
So we have 2, negative 11, 12, and 9. Skip a line, draw a line, bring down 2. 2 times 1,
2,
add down,
9,
times 1,
9,
add down,
3,
times 1,
3,
add down,
12,
and what's that mean?
7,
It is not a 0. Now, what if this should have been a 0 and we make a mistake here somewhere? Like we take 2 times 1, we get negative 2 or something. And we should have gotten 0. What's going to happen to you? You're going to go all the way through all these roots and maybe not find another one. So what does that mean? Yeah, so what is that? Double check. Make 100% sure that every single operation, every time you add, every time you multiply, you've done it exactly right. Because that's the worst thing that can happen is if this should have been a 0 and you got 12 and you moved on and you messed it up. And that's when that comes into play. So make sure if you don't get 0 that you did it correctly. So what are we going to try next? Negative 1. Has anybody tried that? Negative 1 doesn't work. So what would we try next? Positive 3. Anybody done that? 3 times 2. Add down. Times 3.
15.
Add down. What? Times 3. So does that work? Yes. We found the first one. What was the degree of the polynomial we started with? What's the degree of that?
Cube.
3, or cubed. So what is this one? Squared. And that is the goal. Get to a squared or a quadratic. Because we have 4 methods we can use to solve that. We don't have to do synthetic division anymore. Once you get to a quadratic, you don't do any more synthetic division. So what method would we probably use to solve that? Could graph it. Could complete the square. What? Quadratic formula. I would say use that. That would be the best. The bad thing about graphing is if it's imaginary, your calculator won't tell you that. So that's the drawback to the graphing. With quadratic formula, it will tell you no matter what. It will tell you the other possibilities. So that's what I recommend you use. So if we do that, what would opposite of B be? Positive 5 plus or minus square root negative 5 squared minus 4 times 2 times negative 3. That's all over 2a, which is 4. So we have 5 plus or minus. What's negative 5 squared? And those of you who got negative 25 are going to continue to be wrong on that. So then we take negative 4 times 2 times negative 3. Your calculator says positive 24, so you put a plus. 24 all over 4. And what do we get underneath there? Square root 49 all over 4. Square root of 49 is 7. And you must find out both answers. What is 5 plus 7? 12 over 4. X equals 3. What is 5 minus 7? Negative 2 over 4. That's negative 1/2. So how many roots did we find here? 2. How many were we supposed to find total? 3. We started with a cubic, so we had to find 3. What's the other one? We've only got 2 down here. So what's that tell you about 3? It is a double root, so you would need to circle 3 there, because we found 3 twice. We found a 3 by doing the quadratic formula down here, and we also found a 3 up here when we did synthetic division. So 3 is a double root, and negative 1/2 is your other one. F of x equals 2x to the 4. Minus 13x to the 3rd. Plus 23x squared. Minus 52x plus 60. How many roots do we have to find in this one? Got to find 4 roots. So the first thing I would do is find your possibilities. Factors of what? 60 divided by factors of 2. So what are your factors of 60? So we have 1 and 60. 2 and 30. Let's do 3 first. Excuse me. 3 and 20, and he already said 4 and 15. 5 and 12. 6 and 10. 7, 8, or 9 go in? No, and 10 does, and we've already got 10. So that's all. Factors of 2. And then you simply go through and start listing them. Now, when you list, what's the first one you're going to list? Plus or minus 1. And so we do 1 over 1 and 1 over 2, so plus or minus 1/2. I would not go to 60 next. I would go to 2. So we do plus or minus 2 and 1, which we've already got, so we don't write it again. The next one, 3, plus or minus 3 and plus or minus 3/2. Next one, plus or minus 4 and 2 we've already got. So we did 3 and 4, plus or minus 5 and 5/2, and plus or minus 6 or 3, which we've already got again. And I would stop listing about that point. You might try all however many of those there are and not have one, in which case you'd have to go back and start listing again. But probably in this many possibilities, you're going to find 1 or 2, so I would probably stop listing at that point. Are we missing any coefficients or any terms up there? So we have 2, negative 13, 23, negative 52, and 60. And what are we trying first?